2 students, welcome back from spring break. Okay, so we're going to start off by just introducing you guys to the unit circle. I really like that we're going to do this in a video format because normally we build it in class and then it takes a few times to kind of let the content sink in. So I'm going to build the unit circle for you guys. You can rewatch this video as many times as you need to make sure that you understand it. But the importance is that we're going to use this circle to evaluate different trig functions. So it's important that we understand where it comes from, okay? So I'm going to start by talking about what we know about angles in radians, and then we'll do it again in degrees, okay? As we work around the unit circle, as we work around our angles in standard position, we know that this is 0 degrees, this is 90 degrees, this is 180, and this is 270. And then we could keep going, and this would be 360, right? So the unit circle, what it does is it breaks each of these quadrants into 30, 60, 90, and 45, 45, 90 triangles so that we can more quickly evaluate the sine, the cosine, and the tangent values. Okay, so as we work around the circle, there's going to be specific numbers that we care about and that you'll start thinking of and recognizing. Okay, so the first thing that we're going to do is we're going to break all of these quadrants into 3 pieces, 3 equal pieces. So I'm going to actually make this in circle format too. Okay, and pretend that I can draw a circle. That is so terribly lopsided. Oh my gosh. Okay, we're going to try that again. All right, that's a better one. It's not great, but it's better. On the unit circle, one thing that's going to be important that we'll make note of is that the unit circle has a radius of 1. Okay? So when I'm referencing this length from here to here, okay, that length is always going to be 1. Well, that'll come into play when we start looking at the triangles that we're building. Okay, so first I'm going to do is I'm going to split this up and label this in degrees and also in radians. Okay, so we're splitting all of these quadrants up into 3 equal pieces. 3 equal pieces. And what we're going to notice if I focus on this first quadrant, right, 90 degrees, this entire quadrant is a full 90 degrees. If I split that into 3 equal pieces, then each of these sections are worth 30 degrees. So this would be 30 degrees, then 60 degrees, then 90 degrees. And then I'm going to just keep counting up by 30 degrees as I move around the circle. So this section right here is another 30. So this would be 120. This section is another 30. So this would be 150. This section is another 30. So if I add 30 again, I get 180. So that tells me I'm on the right track. I'll add 30 again, that puts me at 210. Add 30, I'm at 240. Add 30, I'm at 270. Add 30, I'm at 300, 330, and then all the way around puts me at 360. Now, if I were to think about this in radians, okay, in radians, when I label this is 0 and this is pi. Okay, I want to look at this top quadrant, this top half of the circle, and think about how many sections did I split that top half into? 1, 2, 3, 4, 5, 6 equal parts. So that tells me that each one of these sections is 1/6 of pi. So what I'm going to do, and this is all the way around, is I'm going to add 1/6 pi as I go around. So this first one, this would be 0 if I go here. This is 1/6 pi. I add again another 6, that would be 2/6 pi, which simplifies to pi over 3, or 1/3 pi. Add another 1/6, that's 3/6, or pi over 2, right? 3 over 6 simplifies to pi over 2, or 1/2. Okay, 3/6, add another, that's 4/6, or 2/3. Add another 1/6, that's at 5/6 pi. Add 1/6, that's 6 over 6, which is just 1. Okay, add 1/6, now we're at 7/6 pi. Add 1/6, now we're at 8/6 pi, which simplifies to 4/3 pi. Add 1/6, now we're at 9/6. 9 over 6 simplifies to 3 over 2. Add 1/6, we're at 10/6. 10 over 6 simplifies to 5 over 3. And add 1/6, now we're at 11/6 pi. And then if I moved all the way around, we've got 12 over 6, which is 2. Okay? All right. Okay, so now we've got this labeled in radians and degrees. Let's go ahead and fill in. There's one more special triangle that we can have. So we have 30, 60, 90 triangles built in here, and it doesn't really make sense right now because I haven't drawn any triangles at all. But you'll see what I mean in a second. Okay, in these specific triangles, we also we want to build in our 45, 45, 90s. Okay, so I'm going to split those 45, 45, 90s. If I think about this first quadrant, right? So this first quadrant is 90 degrees. Half of 90 degrees is going to be 45 degrees. So I'm going to be smack dab in the middle here. And I'm going to actually make these dotted. I'm going to do this because then they'll stand out to me a little bit more. Okay, so smack dab in the middle of the second quadrant, smack dab in the middle of the third quadrant, and smack dab in the middle of the fourth quadrant. Okay, now I know this is 45 degrees. And if I think about what that would be in radians, we'll do radians later. So this is 45 degrees. If I think about the degree marks, notice 45 degrees is 15 degrees away from 30, and it's 15 degrees away from 60, right? So that's going to hold true here as well. So I can take 120 and add 15 to it to get 135 here, or do 150 minus 15 to get 135. Okay, and then same thing here. I can do 210, add 15 to it to get 225. And then same thing here, add 15 to 300 to get 315 degrees. So now I have my unit circle completely drawn out in degrees. If I want to do the radian measures, what's going to happen is these radian values, I'm technically, if I kind of focus on these angles, right? So this is 1, this is 2, this is 3. Okay, so what I notice is I'm actually splitting this. It's hard to see here. Okay, I'm actually going to scoot over a little bit and try and draw this over here for you guys so you can see it a little bit better. So if I do just the 45, 45, 90s, these are smack dab in the middle, right? So this is 0, this is pi over 2 or 1/2 pi, and this is pi. Okay, to do this in radians, I cut this top half into 4 equal sections. So up here, this would be 1/4 of pi. This is 2/4, which is 1/2. This is 3/4 of pi. In this bottom left quadrant, this one would be 4/4, right? Which is why it became 1. Bottom left will be 5/4 of pi. This one will be 6/4, which we already know is 3/2, that we already have that bottom one. And then over here is going to be 7/4 of pi. So I'm going to focus on the ones that we're filling in because we already have the axes filled in. So we're going to be filling in these ones. And we'll start to notice a relationship here. Okay, as we work around the units, or as we work around the circle, we're moving clockwise or counterclockwise, right? These are odds over 4. So 1/4, 3/4, 5/4, and 7/4. So I'm going to go back and fill that in, just thinking odds over 4. Okay, so here, this is 1/4 pi. 135 is going to be, I'll fill them in blue so that we can see them a little bit better. So 1/4 pi, this will be 3/4 pi, this will be 5/4 pi, and then the last one, 7/4 pi. Okay, so now we have our complete unit circle built in degrees and in radians. Okay, what we want to do, we want to go ahead and fill in our special right triangles and the values of the ordered pairs at each one of these different angles. Okay, and this is going to be built off of our 30, 60, 90 triangles. So we talked about those relationships before. I'm just going to kind of review those 30, 60, 90 relationships and the 45, 45, 90 relationships. Okay, so if this were a 30-degree angle, we have that the opposite side would be x, the adjacent side would be x root 3, and the hypotenuse would be 2x. Now, this is the unit circle, right? And what we already said about the radius of the unit circle is really important. The radius is 1. Okay, so that means if I look at this triangle, if I kind of place that triangle in here, okay, I'm going to focus this. I'm going to erase some of this, make it a little bit easier to see, make this less highlighted. Okay, I'm going to build in a triangle in the first quadrant for that 30-degree angle. So I'm going to build in a triangle. Here's my 30-degree angle. Okay, the radius here happens to be the hypotenuse of the triangle, right? So we said this is the radius of the circle. That's also the hypotenuse of the triangle. So if I go over here and kind of work outside here, okay, this hypotenuse is supposed to be 1. So that means the value of x is going to have to be 1/2. So that means this side, this vertical side of my triangle is going to be 1/2. And the horizontal side of my triangle is going to be 1/2 √3, or √3/2. So if I place that in the first quadrant of the unit circle, I'm going to redraw it here because the other one's kind of messy. Okay, here's the first quadrant of the unit circle. Well, actually I drew all the quadrants, but if I think about this, then this is 30 degrees, okay, or pi/6 in radians, okay? The ordered pair that would be associated with that, we happen to know the lengths of the sides in order to get to this point, right? So in order to get to this point, I would travel right √3/2 units, and I would travel up 1/2 of a unit. So this ordered pair at 30 degrees is √3/2, 1/2. Now if I swap that around at 60 degrees, right? Okay, this is the same triangle, it's just going to be at 60 degrees. So 60 degrees up here, what's going to happen is I'm going to swap where the x and the y values are, right? So if I swap the x and the y values, it's going to be √3/2, or sorry, 1/2, √3/2. Okay, and let's just double check that. So as we build this triangle, let's build a 60-degree angle. So if this is 60, now I know that opposite the 60 is supposed to be the x √3. The adjacent side is going to be x then, and the hypotenuse is 2x. I'm going to get this same value for x, right? So remember the hypotenuse of this triangle is still going to be 1. So x is going to be 1/2. And then we're seeing that this adjacent side is going to be 1/2. And then this vertical side is going to be 1/2 √3, or √3/2. And so that's what I'm drawing here. So I'm going right short, 1/2, up long, √3/2. Now those specific ordered pairs can transfer over. This entire circle is perfectly symmetrical, right? So when I look at this, if I look at the bigger circle, okay, I'm going to draw a big one. So this is 30 degrees, and this is 60 degrees. This was 90, this is 120, then 150. Now I have this completely memorized by heart. Eventually, hopefully you'll get to the point where these numbers kind of stick out to you and you know how to draw them in, but you can always go back to just starting and building the whole thing from scratch, right? So I'm kind of just trying to, whoops, this is supposed to be 270. There we go. This is 270, this is 300, and then this is 330. Okay, so at 1/2 here, it's √3/2, 1/2. Up here, it's 1/2, √3/2. Okay, I'm going to reflect all of these over. Okay, so the 60 and the 120 are perfectly symmetrical. Just to get to the 120, you have to go left, right? So instead of going right and up, you're going to go left and up. So it's -1/2, √3/2. Same thing over here. 30 and 150 are perfectly symmetrical. So I'm going to go left √3/2. So that gives me a negative there, and up 1/2. Okay, I can do the same thing here. This point, this 150 is perfectly symmetrical with 210. Okay, so I'm going left √3/2, and I'm going down 1/2 now. The 120 and the 240 are perfectly symmetrical, so I'm going left 1/2, and now I'm going down √3/2, so it's going to be -1/2, -√3/2. And then to get to this point, I am perfectly symmetrical with the 60, right? So I'm going to go right 1/2, and down negative root 3 over 2. And then last but not least, the 30 and 330 are perfectly symmetrical. So I go right root 3 over 2, but instead of going up, now I go down to that 1/2. Okay, and the only thing left that we have to build in, oh, we have to do our axes too, huh? So this was 0 degrees. Okay, if I think about how to get to this point here, remember the radius here of this circle. So the radius, this distance is 1. So to get to that point, I just go right 1 and up or down none. To get to the 90 degrees, I go left or right none, and I go straight up 1. To get to 180, I go straight left 1 and up or down none. To get to 270, I go left or right none and down 1. Okay, the only thing that's left here, we're at 15 minutes. I'm going to try and get this done in 5 more minutes. The only thing that's left here is to build those 45, 45, 90 ones. Okay, so the 45, 45, 90 are all the ones that I drew with a dotted line. Okay, these are all going to have those same reference angles, the 45s, and they're going to be perfectly symmetrical with one another. Okay, so this is a 45-degree angle. Okay, I'm going to build that triangle. I'm going to build that ordered pair on the side here. So remember that this triangle looks like this, where this is 45 degrees and this hypotenuse is 1. If you remember when we talked about a 45, 45, 90, the relationship there is x, x, x root 2. So the hypotenuse is supposed to be x root 2. So we're going to have to solve to figure out what x is so that we know what both the vertical side and the adjacent side are, or the horizontal side are. So I'm going to set x root 2 equal to 1, divide both sides by root 2. So x is 1 over root 2, but now we don't like radicals in the denominator. It's kind of antiquated, but we don't like it because we used to have to divide by hand without calculators, and that was a real pain in the tuchus. And so we rationalized by multiplying by root 2 over 2 in both the numerator and denominator. So x is root 2 over 2. So that tells me these two sides are both root 2 over 2. So all my 45, 45, 90 triangles, all those dotted ones, are going to be some version of root 2 over 2. So the first one, I go into the first quadrant, so it's positive, positive. Okay, over here, this was 135. And this is going to be perfectly symmetrical. I'm just going left root 2 over 2 and then up root 2 over 2. Okay, and then I'm going to reflect down here at 225. I go left root 2 over 2 and I go down root 2 over 2. And then over here at 315, I go right root 2 over 2 and I go down root 2 over 2. And then really quick, I'm just going to go fill those radians in again. So I'm going to zoom this out a little bit so we can see it. There we go. Now it's all in there. I'm going to put the radians in all the way around. Let's see what color would be good to use for radians. Let's do like a bright purple. There we go. Okay. In radians, remember this was 0. This is pi over 6. This is 2 pi over 6, which is pi over 3. This is 3 pi over 6, which is pi over 2. This is 4 pi over 6, which is 2/3 pi. Skip the 45s. This is 5 pi over 6, 5, 6 pi. This is 6 over 6, which is pi. This is 7 over 6 pi. This one is 8 over 6, which simplifies, whoops, I just did 4 over 6, simplifies to 4 over 3. This one's 9 over 6, which is 3/2. This one's 10 over 6, which is 5/3. And this one's 11 over 6 pi. Now I got to do those 45, 45, 90. So I kind of skipped those earlier. I didn't really explain why I did that, but I skipped those because these ones are all not counting by 1/6. Those are my pi over 4s, right? So these are the odds over 4. So I'm going to go back to drawing. This one is 1 over 4 pi. This one's 3 over 4 pi. This one's 5 over 4 pi. And this one's 7 over 4 pi. All right, we finished in under 20 minutes. That's it. You can rewatch the video as many times as you need, but we're going to be working with this circle all this week. All right, thanks for watching.